Okay, so now we're going to do the Huntington-Hill method, which is the method currently being used to apportion our House of Representatives in Congress. So let's follow this method, and we've got an example down here, and I'll just go down to the example for the moment, and we'll see that the first two steps anyway, are the same steps we've used before, but then it changes for us. And there is some similarity in our final steps in getting our answer, but we do have some changes in between. So in our example, the number of salespeople assigned to work during a shift is apportioned based on the average number of customers during that shift. We want to apportion 20 salespeople given the information below. So we have the times of day of the shifts here and the average number of customers off to the right. All right, so let's follow the Huntington-Hill method to apportion these 20 salespeople. All right, so let's notice step one is like what we've done before. We're going to determine how many people each representative should represent, and do this by dividing the total population of all of the states by the total number of representatives. So we're going to find our standard divisor, just as we've done before. We're going to add up the population. In this case, our population are these customers. There's 1,350 of them. And we're going to divide by the number of things that we are apportioning. In this case, that's the salespeople. And that's 67.5. Okay, so that's the same thing we've done on all of our apportionment methods so far. Now let's go to step two. Divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This is called the quota. And this, of course, is the same step we've used in all of our previous problems. So let's take 95 and divide it by 67.5. That ends up being 1.4074. Now on Huntington-Hill's method, it's very important that we take our quota out several decimal places. 4 is a good rule of thumb, so kind of stick to that idea. Let's do the midday now. 305 divided by 67.5. We get 4.5185. And then now let's do 435 divided by 67.5. All right, and we get 6.4444. And lastly, let's do 515 divided by 67.5. We will get 7.6296. Okay, now we are going to take these, and for each one of them, we're just going to drop the decimal off to get the lower quota. So this is 1, this is 4. Notice that we're not rounding, we're just kind of dropping the decimal off. So it's not rounding in the normal way at all. So we've got our lower quota. We're going to use that lower quota to find what we call the geometric mean. So let's notice back here, I just did part of step 3. I cut off the decimal part of the quota to obtain the lower quota, which we'll call n. And now we're going to compute the square root of n times n plus 1, which is the geometric mean. All right, so let's do that right here. I'm going to take the square root, and just for the first calculation, I'll kind of write it out so you know what's going on here. That's slow. So notice the geometric mean is the square root of this number times 1 more than this number. So 1 times 2. So the square root of 2 is what I have there. I'm going to go ahead and stick that into the calculator. And I get, well, just popped somewhere else. 1.4142. All right, so for my next one, I'm going to do the square root of 4, and 1 more will be 5. So the square root of 4 times 5, really the square root of 20, and that's going to give me 4.4721. All right, now let's go to the next one. Our lower quota is 6, so we'll have the square root of 6 times one more, 7. 6 times 7. So the square root of 6 times 7, and that gives me 6.4807. And then lastly, let's do this one. We're going to have the square root of 7, and one more will be 8. So square root of 7 times 8. And that gives me 7.4833. Okay, now for our initial allocation, we have to compare this geometric mean we got to the quota over here. And you'll notice that they tend to have the same first number, so really it's the decimal we're going to end up comparing for the most part. All right, so the number of sales, if the quota is larger than the geometric mean, we're going to round up the quota. If the quota is smaller than the geometric mean, we're going to round the quota down. All right, so let's notice the quota here. If we stare at the decimal portion, 4074, and if we stare at our geometric means decimal portion, 4142, this quota is smaller than the geometric mean. So it's smaller, we're going to round it down to its lower quota, 1. All right, well, let's take a look here. This quota is 4.5185. The decimal portion of that is bigger than 4721. So we are going to round this one up to 5, to its upper quota. All right, 6.4444. Well, 4444 is smaller than 4807, so we're going to round this one down to its lower quota. And then our last one, let's notice the quota has 6296 in its decimal. This one has 4833. The quota is larger. We will round it up, and this will become 8. Now let's add up how many we have in our initial allocation. 6, 12, 20. We've got it, and we don't have to go any further. So let's look at a second one where we may have to go further. So we have 3 people invested in a treasure dive, each investing the amount that is listed below, and the dive results in 36 gold coins. So we're going to apportion those coins among the investors with their invested amount out here. All right, so we have 3 investors. We're going to apportion 36 coins. Let's notice I've already totaled up the amounts of the investments. So let's get our divisor. Our divisor is going to be our 14,900 in investments divided by the 36 coins. And that's 413.89. Now that's actually a repeating decimal, 8888888, and I just rounded to 89. Okay, so we've got our divisor. Let's get our quota. Now remember, to get our quota, we're going to divide each of these investments by our divisor. So let's start with 7,600 divided by 413.89. We get 18.3624. And now let's do 5,900 divided by 413.89. We get 14.2550. And lastly, let's do our 1,400 divided by 413.89. We get 3.3825. Now, let's go ahead and round all of these down, or really drop off the decimals to get our lower quota. So we'll have 18, 14, and 3. And let's do our geometric mean. All right, so here we'll have the square root of 18 times 19. And that is going to be 18.4932. And here we'll have the square root of 14 times 15. That is going to be 14.4914. And then we'll have the square root of 3 times 4, or the square root of 12, which will be 3.4641. Okay, so now let's compare. Notice the quota has the same whole number as the geometric mean, so let's just compare the decimals. 3624 is smaller than 4932, so we want to round this one down. This will be 18. I guess I should put an initial over here. All right, and then 2550 is smaller than 4914, so we're going to round that one down. And then finally 3825 is smaller than 4641, so we're going to round this one down to 3. And if we add these up, we're going to have 3235 coins allocated. All right, so let's go to our next step, because we are going to have to do the next step here because we don't have the proper amount allocated. We need to allocate 36. We've allocated 35. So just like we've done before, so notice it says if the total from up here was less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. So we are going to reduce the divisor. It was 413.89. So I'm going to use 410. That's less than 413.89. So D equals 410. All right. And let's see what we get. Let's divide our 7600 by 410. I'm going to get 18.5366. Let's divide our 5900 by 410. We get 14.3902. And then lastly, let's divide our 1400 by 410. And that is going to give us 3.4146. Okay, so now we're going to compare this modified quota to the geometric mean using the same rules we did before. If the quota is higher, we will round up. If the quota is smaller, we'll round down. So if we compare this one to the geometric mean, let's notice that 5366 is higher than 4932, so we're going to round up to 19. This one, 3902, is smaller than 4914, so we're going to round down to 14. And then 4146 is smaller than 4641, so again we're going to round down. And now if we add these up, we have managed to allocate 36 of them. Of course, I can call this my final allocation because they are all allocated.